All right, so last year or you guys in grade 10, used like SOHCAHTOA kind of trig, sine equals opposite over hypotenuse, and you did all that kind of stuff, and you worked with trig to find missing sides in right triangles. This year, we are going to extend that past right triangles a little bit to include, all kinds of triangles. So let's just do a quick recap of what we did in grade 10. So first of all, you guys had to, determine which angle you were going to use. Now, there was three sides. There was the opposite side. Now, well, first of all, let's start with the hypotenuse. Remember, this is the hypotenuse. It's the longest side. It's opposite the right angle. It's always that kind of one that's like not squared up, right? So it's hypotenuse there. Now, since we're talking about the 72-degree angle, this is the opposite side, opposite the 72, and this is the one adjacent, the one right next to the 72-degree angle. And we have to figure out how to find x. Well, we need to use a trig function that links together the opposite side, O, with the adjacent side, the one that we know, the one that we don't know, and the one that we know. So the trig function that uses opposite and adjacent would be tan. So you guys remember last year, maybe you went, sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. Okay? So SOHCAHTOA. I remember when I was in just a lad in high school, I remember going like, sin, oh, cozy, ah, and hey, nice tan, ooh, ah. That's just how I remembered it. We didn't have SOHCAHTOA back when I was a kid. So no matter how you slice it, we need to use tan here. So we would set up, well, tan of an angle. Remember that there's theta, a Greek letter that we use to stand for angles often. So tan of theta is opposite over, is opposite over adjacent. So then when we plug in what we know, we got tan of 72 degrees is equal to the opposite side over the adjacent side. Okay. Now, this little formula here, we could multiply both sides by 7. And x is equal to 7 times tan of 72 degrees. And if we work that out, we get 7 times tan of 72 degrees gives me 21.5. So that side there, so make sure I'm in the right mode, I'm in degrees. So 21.5, we could round this off to whatever we want to do. Let's just do it to one decimal place. So 21.5. And the unit is meters. Okay, so we use trig that way to find missing sides, and we also use trig to find missing angles. So in this one here, it's the angle that we don't know. Okay, so what do we have to work with? Well, this is the hypotenuse side, so let's label it right away. Across from the theta is the opposite, and next to the theta then is the adjacent. So we label the sides. So in order to find the angle, we're going to work with a side that we know, the adjacent, and another side we know, the hypotenuse. So we have to now choose the correct trig function that involves both of those things. So a over h is cosine, so cosine of an angle is adjacent side over the hypotenuse side. Okay, so fitting in what we know cos of theta is 5 is the adjacent, 8 is the hypotenuse. So this is one thing where this time we don't know what the angle is, so we have to use cosine kind of backwards. That is, we know what the ratio is, we just got to use our calculator to work backwards to find what the angle is. So angle theta in this case then is going to be second function. So second function or inverse means you're using your calculator sort of to work backwards from the cosine ratio of 5/8 to find out what angle would give you that. So notice it's opposite what we did in part A. Okay, so you guys kind of did that before, so let's take up the calculator. We're going to go second function cos -1 of 5/8. So that's 51.3 degrees. All right, 51.3 degrees. So you guys hopefully, you did lots of that last year. If you have calculators this year, obviously if you have the TI-83, that's the one that I'm kind of using on my screen. But if you don't have that, you're going to have to figure out, make sure that you're in the correct mode. If you're getting weird answers as you're working along with me, you might be in radians other than degrees. We need to be in degrees, so your calculator needs to be set to that. And some calculators have you type the numbers first and then press tan. So it's really just figuring out how to make your calculator work with that. So if you have any questions, make sure you ask about that in class. Okay, but what we're trying to do this year is extend the use of sine, cos, and tan to triangles that aren't 90-degree triangles. And in order to do that, we have to settle something in this chapter. That is, how can we take sine, cosine, and tan of angles greater than 90 degrees? How can we do that? And what do the answers mean? Well, let's take a look at these two things here. I'm going to go find the sine of 50, and that's 0.766. 0.766. Okay, the sine of 130, let's figure out what that is. Sine of 130. It's the exact same thing. Okay, that's kind of weird. So 0.766 ... All right. So why do we get the exact same thing? We got to figure out, if we're going to be using trig with these larger angles, we got to figure out why that is. Let's see if the same is true with cos. So cos of 50 is 0.642. I know it's 7. I'm just going to go ... And cos of 130. Okay, it's this time, it's not like sine. It's not exactly the same, because this time it's the same number, but this time it's negative. So negative 0.642 ... Okay, so those are almost the same. And just for the heck of it, let's check out the tan of those numbers. So tan of 50 is 1.19, and the tan of 130. Okay, again, this one here, they're opposite signs. It's the same number, but just one's positive, one's negative. So why is it the sine is the exact same number? Why is it the cos, those are opposite signs? And why is tan kind of the same number? Okay, except one's positive, one's negative. So we got to figure out what is, first of all, in this unit, we're going to figure out what is the connection between, say, 50 and 130 degrees. Why are they giving us numbers that are close to the same? Next thing we're going to try and understand in this chapter is why is sometimes those different connected. I will tell you that 50 and 30 are connected in some way. But why is it that the sign of them in this particular case, are they both positive, but the cos of them, in this case, one's positive and one's negative? And the same was true with tan. So that's what we got to try and figure out. And in order to do that, we're going to look in the next section at what an angle is in standard position.